Hello, ladies and gentlemen. This is Mr. White coming at you from room 228. This is one of the interesting things that we can start doing with the LMS and the document camera is I can start doing some videos for you to explain how to do some of these questions while you're not in class, and you might want to take a look at it online to help you out. So we worked with the sine law today, and what I'd like to do is do a little bit more work with it. Now you're going to notice at the very top that we have a triangle here, and the first thing that we have to understand is that triangles, when I label them, so if I'm going to talk about triangle ABC, I can put the A, the B, and the C anywhere that I want, but once I do, the sides are then going to be fixed. So if I call this vertex capital A, then the side opposite it is going to be little a. And if I call this vertex or angle C, then the side opposite it is little c. Now the sine law itself is pretty straightforward, and it talks about a ratio. It talks about a ratio between side lengths and the angle opposite that side length. So this is the sine law, very different than SOHCAHTOA. It's not opposite over hypotenuse because it's not a right angle triangle. That's something that we should make clear right now. Not a right triangle. Okay, so we're not going to be using SOHCAHTOA, absolutely not, and we're not going to be using Pythagorean theorem. Those won't work here. Okay, so now the actual setup, now we've got three of them here, and what it says is that the side A over the sine of the angle opposite it is equal to the side B over the sine of the angle opposite that. Now that ratio holds for all of the sides and all of the angles. So here you can see that side B divided by sine, the angle opposite that side, is equal to side C divided by sine, the angle opposite that. Now we don't have to start with the sides. This is to find a side. If you want to find an angle, then all of these would be rewritten as sine of A over top of the side length opposite is equal to sine of B over top of B. Or this one would be sine of B over top of the side opposite it equals sine of C. And finally, the last one would be sine A over A equals sine C over C. So what's important here is that we have both of them that we can work with, and what I would suggest is that this would be to find a side you put the side on top, and this one to find an angle you put the angle on top. And that's going to make our life so much easier as we work through our questions. So, the sine law itself can be used to solve any triangle, not just, we're not working with right triangles here, because it can be used to solve any triangle, when two angles and a side are given, or two sides and an angle opposite one of the sides. So there's two different cases here. We can use the sine law when I have two angles. So let's say I give you that angle, and I give you that angle, and any other side. Let's say this side. So I gave you two angles, and I give you one other side. We can use the sine law. Let's see. So looking at this, this is what I don't know. So very easily we could say that we can find A by going the sine of the angle opposite, which is what they gave us, equals C over sine of the angle opposite C. And you're going to remember that they've given us this, they've given us this, and they've given us this, which is going to allow us to get A. This is one situation where we would use this. The other situation is when you have two sides and an angle opposite one of the sides. So let's say I give you two sides, and I give you an angle opposite one of those sides. So if we look at this, I have the setup here for the sine law. And what can I determine? I can determine C, angle C. Why? Because using this angle, if I wanted to find it, sine of C over top of little c, which they gave me, equals sine of B over top of little b. And those are the two ways that we use this law. Okay, let's do our first example. Our first example, we're going to have to make a triangle. It says given triangle DST. They tell you that angle D is 47 degrees, side D is 7.8, and side S is 10.6, and they want to find the measure of angle S. So, we're going to draw a triangle. Don't draw any special triangle like a right angle triangle, because then you're going to be tempted to do things that you can't. I can label this D, S, T. That's fine. I could have put the D here or the S here or whatever. But as soon as I do label it, this becomes the side opposite the angle. So this is going to be D equals 7.8. This is little s, so it's 10.6. And this is angle D, so that's 47 degrees. And what they want us to find is angle S. So, let's see what we've got. I see that I have the sine law pattern setting up here, and I can use the sine law pattern here. So the sine of S over top of the side length opposite it equals the sine of 47 over top of the side length opposite it. Now, if we cross multiply and then divide both sides by 7.8, we can shorten that up simply by doing this. 10.6 sine of 47 over 7.8. Now, many of you are getting to the point where you can do this, and this works out really nicely. Some of you still want to show the cross multiplying, show the 7.8 on this side, divide both sides by 7.8, and that's fine too. Using my calculator, I'm going to do 47 sine times 10.6 equals, divided by 7.8 equals. Now be careful, do not round this number. This number, you need all of it because you're going to use it to calculate the angle of S. What you have to do is you have to do the inverse of this whole number. Now, I'm not suggesting that you write it down. I'm writing it down so you see what I'm doing, but I'm going to hit second function sine, and I get the answer of about 84 degrees. So angle S is equal to approximately 84 degrees. And that is how you use the sine law for example 1. I'm going to stop now, and then I'm going to do another video for example 2.